Hello and welcome. My name is Anil Rao. Vikas and I have the privilege of having this conversation first thing after lunch for all of you guys. So hopefully it's going to be something where we build energy, drive up. I'm not going to make you all stand up and raise your hands and do jumping jacks or anything, but the topic itself is going to go there. So like I said, I'm Anil Rao. I'm VP and GM at Intel, responsible for security and systems architecture. Vikas?
Yeah, thanks, Anil. And I'm Vikas, and I'm the head of product for Azure Confidential Computing. So the first thing you guys need to do is start dancing. No. Thank you so much for being here. Anil and I have been working on this confidential computing journey for a while now. And in many ways, this is like a great milestone for both of us to be able to share this with you on how the evolution of confidential computing is happening. So let me first start off with what are we seeing in terms of customer challenges, right? I think overall, the cloud in general, everybody's on it, right? If you missed the keynote today, there's so much happening in the cloud, along with what we are seeing with AI today. But what we are also seeing is, when you're running in the cloud, there is a higher level of assurance in some cases that need to be met, right? Sometimes there are projects blocked. There are new services, there's new collaboration that could be done, but those are not possible because of the compliance and regulations reasons that exist that prevent sort of these workloads to run in the cloud. And despite sort of many of the advantages that you see in the cloud, applications may have sensitive data that may be stuck on-prem, that may be concerned about sort of data security risks, data compliance risks when they're running in the cloud. And a lot of these are applicable to many of the regulatory or legal elements that organizations have to deal with when running in the cloud. And in general, many applications just have sensitive data, right? And they want a higher level of assurance. They want to be able to verify the state of their cloud environment so that they can run on it and have the complete control over the data during its entire life cycle, from the time it is created to the time it was destroyed. And in many cases, confidential computing was created for one of these reasons, to provide a higher level of assurance for the data that you're running in a cloud environment. So what is confidential computing, right? We all know that we encrypt data at rest, we encrypt data in transit. Right? This is industry standard, right? Like today, you can take my laptop and run away with it. There's nothing you're going to find because data is encrypted at rest using BitLocker as an example. Similarly, your data in the cloud, it's encrypted at rest on the SSDs or the storage devices that you use. Similarly, data in transit, it's a standard. We don't do HTTP anymore. We do HTTPS, we do TLS. If you go to a browser, and you go to http yahoo.com, it'll tell you it's insecure. It automatically transfers you to https yahoo.com. That's the state of evolution of encryption. And confidential computing is that missing third leg of the three-legged data lifecycle stool, which has now been available for customers to use at scale. And what confidential computing does is it protects that data when it is in use, when it is in memory, when it is being computed upon, so that inside that trust boundary, data appears in the clear, but outside that trust boundary, data appears as ciphertext. So confidential computing, there are two key takeaways from this slide that you need to understand so that you can become dangerous after this. First, confidential computing is the protection of data when it is in memory. This has not been done yet. It's a new innovation that Intel and Azure have been leading the evolution of this technology. The second key takeaway is because now we have confidential computing, data can stay protected from the time it is created until it is destroyed with a key that you own, right? And that's sort of the big picture for confidential computing. And what does it protect against? It protects against insider threats, whether you're worried about threats in your own organization or threats where your data is running. It protects against malicious code. For example, the Azure hypervisor is already battle tested. We have a $250,000 bounty on the Azure hypervisor. But what confidential computing does, it puts the hypervisor outside the trust boundary. And there are new use cases that confidential computing helps unlock. such as operating on multiple data sources where you're sharing without actually sharing. You're getting analysis, you're getting value out of the data without actually sharing the data with anyone else. So we see confidential computing as a natural evolution of how data should be protected. And when we talk about confidential computing, we think of it as a standard. This is something that Intel and Azure were one of the co-founders of the Confidential Computing Consortium back in September 2019. And the definition you see on the screen is something that we have worked with the Confidential Computing Consortium and the larger industry to make possible, which defines confidential computing as the protection of data in use by performing that computation in a hardware-based, a tested, very, very important element, a tested, verifiable, trusted execution environment, or a TEE. And a TEE tells you that the definition of a TEE is you have verifiable assurance for your data and code integrity. Nobody has modified my data, nobody has modified my code before I actually operate on it. You get that assurance. And of course, that the data itself is confidential. Only the code that should have access to the data will have access to the data, and anybody who's not explicitly granted access to the data will not have access to the data. These are some of the founding principles of how we think about confidential computing. And the way, Anil, if you want to take this one.
Yeah, let's talk about one level more detail from what Vikas spoke, what confidential computing is. Think of it as a way in which you create, like Vikas said, a trusted execution environment to operate on your sensitive data. So it's almost a region inside of memory that you dedicate and say, this is where my data is going to be safe and secure. Anything outside of a trusted execution environment, whether it is software stacks, other virtual machines or other applications, or even hypervisor and cloud-related administrators, they're all outside of this trusted execution environment. So what happens inside of this trusted execution environment? Essentially, once you create this trusted execution environment, it provides kind of like three basic capabilities and functionalities. The first one is isolation. With isolation, what happens is that anything and everything which is not inside of a trusted execution environment doesn't have access to the data in the clear. You can kind of like walk through memory, you can do privilege escalation, and you can kind of like dump contents of the memory. You're not going to see the data in the clear. Data is always going to be encrypted from outside of the trusted execution environment. So then, like Vikas mentioned, attestation is a key element of creating confidential computing. The process and methodology you follow is that your application, which is completely encrypted, it can be AI models, it can be AI data, or it can just be traditional applications and traditional data. Completely encrypted, you maintain the keys, and once you know the underlying infrastructure is safe and secure and it has met all the goals that you want to do, whether it is your custom policy or whether it is making sure that the latest and greatest version of the firmware, latest and greatest version of the hypervisor, they're all kind of like in that particular infrastructure. Once the attestation process is done, that's when you release the keys. And once you release the keys, the application then decrypts the data and the application information inside of the trusted execution environment, and normal operation follows from there. The beauty of confidential computing is that you don't need to make modifications to your applications. Your applications run the way it is. And the second is that you don't go through any major drop in terms of performance. It may be 1 or 2% in terms of drop in performance depending on what types of applications that you use. So you will get the performance benefits of traditional compute, but you'll also get the benefits of confidentiality in adopting confidential compute, whether it is for your private or for the public cloud.
Yeah, absolutely. And I think one element that Anil just talked about that I want to kind of reinforce is this element of verification or attestation, right? And the attestation language itself is something that we are working on as part of the standard.
That's right.
Which is as part of the IETF standard. Now, one of the elements that you get out of it is, I want to know, is my operating system the operating system I expect? Does it have secured boot? Does it have measured boot? Do I know that all the layers in my stack are something that I can explicitly verify? And that verification report is generated by the CPU, right? So you're verifying your entire stack with an attestation report, and only when the attestation report, and again, it's an optional component. You don't have to actually use it if you don't really need to, but it's an optional component.
But it helps using it for auditing purposes.
Absolutely.
And all of those things, right?
Definitely important for auditing, definitely important for additional assurance that you need. But this is one of the key elements of what makes confidential computing tick. So the way to kind of think about confidential computing is we already encrypt data in transit and at rest. So when we talk about confidential computing, it's a foundational layer. And our vision with confidential computing is that we are building the confidential cloud, where eventually all workloads, as the technology matures, operate essentially in a confidential environment where computing itself becomes confidential. Mark Russinovich the Azure CTO, is doing a talk on this again in his Azure AI Innovations section that I think I recommend people to go look at. But generally, the way you should think about confidential computing is it's this circle, if you may, that's been shown on the screen, is it helps you protect the data during its entire life cycle, from the time it's created to when it is stored to when it is transported until it is destroyed. You stay control of your data. And the benefits obviously are that you're unlocking the value in the data. As we mentioned earlier, there are some data sets that regulations prevent sharing the data with someone else. As in, like if you want to do anti-money laundering, or if you want to do new drug development, regulations prevent customers from doing that. So these sort of technologies help you unlock the value in the data that you already have by getting that additional assurance. It helps you be compliant with regulations that are happening, and we see the regulations, rapidly evolving, right? Some of them we are seeing in the APAC region, some of them we're seeing obviously in EU. So there's a ton of sort of interest in how we ensure, as custodians of data, that we are making sure that the data stays protected. And confidential computing follows zero trust principles, right? It's trust and verify. It's explicit trust rather than implicit trust that you're giving to your compute environment. So
the beauty of this, what Vikas just said, is that you own, you maintain, and you have control of your applications and data, regardless of where you do computation. So you can start thinking about what that means, right? You can kind of like leverage compute anywhere, whether it's in the public cloud or the edge. These are areas where confidential compute enables you to take advantage of computation anywhere without necessarily worrying about, is my data secure? Do I have to make my infrastructure choices based on the security of my data, or even like compliance or protection of information that is maintained in the data? All of those are off. You can kind of like focus on saying, what's the most efficient way to do this? Where is the most efficient place to do this? Mm-hmm. So you can adopt cloud, you can adopt some of the beautiful things that you heard in the conversation that Satya mentioned this morning.
Yeah, and I think like when we were thinking about like how to present this slide, how do you talk about confidential computing and where it's applicable in? It's like asking a question, where is HTTPS applicable in, right? It's actually applicable everywhere. But I think in terms of, this technology is still maturing, rapidly evolving. So I think what we can give you is a snapshot of where we are seeing the interest come when we talk to customers. And I think when we kind of talk to customers is, a lot of it is happening in regulated industries, whether that's, healthcare, where multiple drug companies are trying to work together to combine their data to get a new sort of drug development, new analysis. We talk to a lot of customers, and I've had actually neuroscientists come and tell me that, hey, now I can actually leverage this data for new drug applicability that previously I was not able to, right? It unlocks all of these new data sets. The other sort of use case that we see in financial services, for example, we see a bunch of these use cases where financial services are trying to run analysis with their models, and they want to make sure that the models themselves are kept private. I'll talk a lot about the use cases in the future of how we are seeing customers use it. But many of the use cases that we see, for example, are in these confidential multi-party analysis or data clean rooms, as an example, where multiple parties come together and they are able to solve sort of their analysis without actually sharing the data. Another use case that we see a ton right now is in public sector. One of the things that we are spending a ton of effort on is Microsoft Cloud for Sovereignty, where we enable these sovereign landing zones for our public sector customers, and confidential computing is one of the options that's available for customers for their highly restricted data sets or highly restricted workloads. And in terms of usages, we see a ton of usage. I already mentioned collaborative analysis. We announced the first confidential GPUs today. So we see a ton of use cases in visualizations, simulations, obviously AI, privacy-preserving analysis with advertising, especially with what's going on in the industry with third-party cookies, eventually going away. So these are some of the use cases that we see around confidential computing. Is there anything else you want to add to this?
I think the reality is that where are we seeing use cases now? If you ask me 5 years from now, you will all ask, why is my compute not confidential by default? And I think that's where we're going from an industry perspective. So here are some of the initial set of use cases that we mentioned. I'll give you another example, multi-party compute, especially when it comes to healthcare, digging a little deeper. If you look at some of the use cases that we have between Microsoft and Intel, you'll see that a single hospital may not have all the data in order to do thorough training, because some of the data is not comprehensive, and some types of diseases are not that common. But if you pool in multiple hospitals, you get enough in terms of data for you to make good model training happen, which results in much better use of AI inferences in the future. So these are some of the use cases that we're starting to see. But that just is the beginning. There is tremendous amount of opportunity that we will see as we move forward as well.
So let's talk about what we are giving in public preview today. And one of the things that I'd love Anil to talk through is how they think about Intel's confidential computing portfolio, and then I can talk about what's exciting in public preview.
Yeah, look, from a confidential computing, Intel has by far the most comprehensive set of offerings in the industry today. We started off with our initial technology called Software Guard Extensions, or SGX. The beauty of SGX was that we focused a lot in terms of security. We said, let's give full control to software and application developers. And once we give them control, they can go and decide where is sensitive data, what do they want to protect through confidential computing. It can be kind of like a simple function in your application, or it can be a single line of code, or it can be a complete application. So that's why you had the flexibility. And for those of you who have used our SGX technology, we initially had an SDK where you use in order to use the isolation attestation mechanisms that we spoke before. Now, and Microsoft offered some of these things as part of the DCSV3 and DCDSV3 series in terms of solutions. We also augmented it with a library OS where you can not necessarily use an SDK and make application changes, but you can automatically run your entire application inside of a confidential environment with SGX as a technology. So these have been around for a while, battle-tested, rugged in terms of technology and solutions, and our partner Azure has been offering this for a while. So we most recently have also announced availability of a new technology called Trust Domain Extensions. Trust Domain Extensions starts appearing in the 4th generation Xeon series. And the beauty of Trust Domain Extensions is that you actually don't need to do anything. You just go in and say, instead of me getting a virtual machine, I'm going to go get a confidential virtual machine. And once you get a confidential virtual machine, you continue to use the confidential virtual machine just the way in which you use a traditional virtual machine. And the entire virtual machine now runs inside of a trusted execution environment, and you get and gain benefits out of it. Now, as we introduced SGX and TDX as a technology, and like Vikas was talking about an attestation technology, how can Intel help here? Because at the end of the day, we wanted to, and the industry wanted, operator independent, uniform attestation solution, because in certain cases you're going to deploy your application maybe in your private cloud. In certain cases you're going to go do it in the edge, and in certain cases you're going to go deploy it in Azure or any other cloud as an example. So how do you get that independent uniform attestation mechanism? And that's where most recently at the Intel Innovation event we launched Trust Services, Intel Trust Authority, and we've been working with Microsoft Azure, Vikas, Mark, and team for a while now. They've been hugely supportive of this. And you as an end customer can leverage either Intel Trust Authority for attestation or Microsoft Azure Attest for attestation as well. So the beauty of this is that through our mechanism, you will be able to not only use the confidential environment, but you'll also be able to verify. You'll also be able to have trails for auditing. So that entire comprehensive set of solution is what we bring to the portfolio in collaboration with Azure.
Yeah, and I think one of the things that I think is important to kind of talk about is confidential computing has been a journey over many years, right?
And it will be going.
And it will be going
yeah.
forward. You're absolutely right. And Intel SGX was a great sort of first step for us to explain to you, what is the value of confidential computing? How do you protect data in use? And we see a ton of customers adopting it, right? Signal Messenger, for example, is one of the biggest customers sort of in this space that runs entirely on confidential computing. But then, as we've been talking to customers, we realize that, customers want an easy button, path to confidentiality. And that's sort of what TDX enables, because the D series, is a standard Azure VM, and we've created a DCE series where instead of deploying to that, you deploy to this one. You don't have to change any of your code, right? It's essentially no code change, lift and shift, sort of a VM solution. So rather than deploying to a VM, you're deploying to a confidential VM. And now what you get is whole VM sort of isolation. And that's sort of the new innovation that we've been working with Intel on. And one of the great things in this partnership is we've been working with customers like you who give us this amazing feedback on we want choice in our attestation providers. And this is why we did the work with the Intel Trust Authority to give customers that choice. Hey, if you want to use a service that Microsoft provides, you can use that. If you want to use another service, you can use that. But the point is that customers have that choice, and attestation and verification are key elements that we think is super valuable, especially along with where you can just take your code, your VM, and just redeploy, and now you're confidential. There's a ton of value in that.
Yeah, and I'm also proud to say that in partnership with Azure, we offer by far the most comprehensive solutions in the industry. You can use SGX, you can use TDX, you can use Intel Trust Authority, you can use Microsoft Azure Attest in order to do what you want to do. So you'll not get this type of solution anywhere else.
So with that, I think one of the things that we are super excited to announce is the public preview of Intel TDX-based confidential VMs. And this has been part of the journey that we've been doing with Intel. And in some ways, we are super excited because these are our most powerful confidential VMs yet, with up to 128 vCPUs, 766 GB memory. These are perfect for general purpose or memory optimized sort of workloads. They are integrated as part of our general sort of confidential VM capabilities. They provide standard capabilities that we provide, such as attestation, disk encryption, confidential key management. And we've taken these Intel TDX-based confidential VMs a step further with what we are calling ephemeral sort of TPM-based confidential VMs, where your confidential VM is a VM that essentially is a unit by itself. There is no dependency on any other service except the confidential VM that you're deploying. And that's where you have a choice of using an independent attestation provider or an independent key management provider in case you want to do those sort of separation of duties. But in many ways, these sort of confidential VMs gives you, OS disk integrity as an example, ensuring that your disks are encrypted. It gives you attestation, confidential key management, all of these elements that are now also available, with the work that we've done with Red Hat or with the SUSE Linux to bring these capabilities. Obviously, Windows is also supported. But the work that we're doing with Intel on TDX, gets into the Linux kernel. And at that point, it's going to be upstreamed, and essentially, all distros will start carrying this capability as well. So we totally see this as a foundational element of how VMs evolve in the public cloud.
Yeah, just to add to that, because if you go to the next slide, we already have a numerous amount of distros: Canonical, Ubuntu, Red Hat, SUSE, Windows Server, Windows 11. All of these are guest OSs that are ready to go, right? And with our 4th generation Xeon series, we also collaborated heavily with Microsoft in order to make the right kind of changes in the hypervisor in order to enable confidential computing and confidential virtual machines for you. Because would it be fair for us to say that if a customer is using traditional VMs, in order for them to get up and running with a confidential VM, it's just a matter of hours and not days, months, weeks, right?
It's
very
just
quick.
redeploying.
Yeah.
Just choose a different VM size. Obviously, you got to move to a newer guest OS, right? Because that's where all the guest enlightenments are. But I think in general, you're not changing your code.
Yeah.
Right? You're just redeploying, and boom, you're ready to go. That's sort of what we see as where we see confidential computing evolving. It becomes part of the fabric. It's just there, right? And again, this is going to be, as Anil mentioned, we've been doing this for a while. It's not something that's going to happen overnight, but we totally see that this general evolution moving in this direction. The other thing, I think, Anil, if you want to talk a little bit about sort of how attestation works in this environment.
Yeah, let's first talk about what attestation is, right? Attestation is actually a cryptographic confirmation of the state of the confidential computing environment. A lot of times when you go through the mechanism for releasing the keys, you want to know that the environment where you're operating is secure. The environment you're operating is exactly what you expect it to be, including some of the custom policies that you may define, right? You may define a custom policy which says that I want the latest version of maybe the hypervisor patch, or I want a latest version of an OS patch. These are all things that you may want to decide and define. So attestation is a mechanism where it goes in and says, I will give you the state of the system. I will have an immutable way in which that state of the system is maintained as a record for your future auditing or any of those purposes. That's exactly what attestation is. Typically, from an attestation elements perspective, you want to make sure that it's on a genuine Intel processor. You want to make sure that the microcode patch is updated with your policy. In certain cases, you may say, I'll give a certain amount of leeway here, or no, I want to strictly adhere to a certain set of policy. The launch is done using an authentic firmware. And last but not least, the manifest matches what you have defined in terms of the policy. Once you do these things, then the attestation solution gives you a token. You present that token to your key engine. We have collaborations with our partners to integrate with key engines as well. And there you release the key. And once you release the key, then the decryption happens inside of the trusted execution environment. And everything else processes and progresses as defined. So this entire process of making some of these changes, by the way, we have open source code available to go through the type of attestation solutions as well. And you can use that to point to Intel Trust Authority or Azure Attest, and you have that flexibility as well. So once you do that, then your application is up and running. That's why Vikas and I feel like it's probably going to take you hours in order to do it, and not weeks or months in order to have something of this up and running. So the Trust Authority, the benefit that Intel Trust Authority provides is it's an independent source for attestation. It's like what Vikas was talking about, trust but verify, right? It's unified for public, private, on-prem, edge cloud, unified solution. It's a SaaS offering, something simple, and you can quickly use and deploy in your applications and solutions today. And we collaborate with Azure to bring it to you as an end customer so that you have the flexibility and you also kind of like get up and running with solutions in Azure as quickly as possible.
So with that, let's talk about how we are leveraging sort of these technologies in Azure. So one of the things like we've done with confidential computing is we've created our own service for a particular specific use case, as an example, which is we are announcing in public preview the Azure Managed Confidential Consortium Framework. We've had this CCF, Confidential Consortium Framework, SDK, open source for a while, and we've seen a bunch of customers use it for these confidential multi-party applications because it helps with governance, building trust in the nodes, ensuring that the right organization has the ability to perform the transaction rather than not, right? So it helps with building these sort of scenarios. Now what we've done is we've taken that SDK and we are making that a managed service because this gives you a hassle-free experience to host and run your entire secure network in this confidential environment, and something that we've been working with on Intel on. And when we talk about Intel-based confidential computing services on Azure, the way we look at it is the underlying underpinning of everything is the hardware, because that's sort of what gives us that hardware-based root of trust to give us the attestation report. But on top of that, there is a platform which starts with enabling these virtual machines. For example, the SGX virtual machines we talked about, the new public preview Intel TDX-based virtual machines that we are talking about, the confidential virtual machines. And on top of that, we are also enabling containers as an example. And we are also enabling services that run on this infrastructure, first-party services as an example. One of the services that we talked about is the Microsoft Azure Attestation Service. That itself is a confidential service. The other is Managed HSM, which is a key management service. We've taken our Azure Key Vault service and completely sort of reimagined how that would run inside an enclave to make sure that the keys are protected and it's a much higher sort of level of security, using the best in class abilities to provide this key management solution. In addition, we see a bunch of customers using confidential computing for also services. So, one that we have enabled is confidential SQL. So that's SQL always encrypted that runs inside these secure enclaves that gives you, for example, row-level assurance that your records in SQL are confidential as well. So these are sort of the evolutions and innovations that we are doing on sort of the confidential computing technologies. One that I think I love to, and we've actually announced a few features on this today, is Azure Confidential Ledger. It provides you a tamper-proof audit logging capability that's backed by a confidential computing environment. This is also a choice that you have that you can enable as part of the SQL Ledger, as an example. This becomes one of the providers behind the scene. But in general, the way you should think about it is the hardware enables basic capabilities. There's platform level elements to run your code inside, like virtual machines or containers. And then services are the ones that light it up, where you're just using a service that happens to be confidential. And you have that extra level of assurance in that case. Anything you want to add?
No, I think you got it all. It's like making sure that as we go forward, you have applications and services that you can leverage, not just from an infrastructure as a service, but also like a platform as a service, and these elements are where we're going together.
Yeah. So let's talk a little bit about what we see in terms of use cases. Beekeeper AI has been one of our close partners for a while now. They are an innovative startup that spun out of University of California, San Francisco. We've been working with them for a while. And what they enable is this unique use case of creating these trusted execution environments, or these enclaves, for these multiple healthcare companies. Somebody brings their data, somebody brings their model. Those are two entirely different organizations. And what Beekeeper AI allows them to do is it creates an enclave for them, where the data provider brings their data, the model provider brings their model, and they are operating on that data, the output comes out, and the compute environment is essentially destroyed, and there's nothing that remains. The only compute that happens in that environment, inside that enclave, is the code that should be operating in that environment. And Beekeeper is one of those innovative startups that is doing a ton of work to make this happen.
The interesting thing about Beekeeper is that nowhere, through no process, does sensitive data get out of the enclave. It doesn't matter where you're running it. The sensitive data is inside the enclave, and you don't lose control of the sensitive data. You go through an attestation mechanism, and each individual hospital or each individual entity releases the keys once they know that the entire environment is safe and secure. So you go through a cumulative model training so that at the end of the training, you have a rich set of models that you can use for these rare diseases, and that's the beauty of what they've done.
Another innovative company that we've been working with is Fireblocks. They provide the simplest and secure way to manage these digital assets. And they've been one of the innovators in this space since quite early. They've been using a confidential computing environment to manage their assets, to run sort of these multiple financial institutions, leveraging their infrastructure inside a confidential computing environment. They've started off with leveraging Intel SGX for these digital assets scenarios, and they are continuing to innovate in this space with use cases around helping financial institutions enable these sort of new use cases that were really hard to do, or pretty hard to do without it. So the other sort of use case that I want to talk about is also one that we've been working with Decentriq. Decentriq is one of our partners based out of Switzerland, which is enabling the SaaS service, where they've been working with Goldbach as an example, where they are enabling the SaaS service to exist, where the data providers bring in their data, they get an attestation report, and then they are operating in that environment. And Decentriq helps multiple parties work together in a SaaS environment where the parties don't have to set up their individual environments, and the parties don't have to trust Decentriq as the solution provider. They don't have to trust Azure as the cloud provider. They don't have to trust their employees. The only thing that they trust is the code that operates on that data, right? So this is, again, a new paradigm of how we see compute evolve in the future cloud environment. I guess the other thing I also want to add, this is another sort of use case where we see a bunch of these customers wanting to interact because of the third-party cookie and the expanded visibility into how retail and marketing data is being leveraged with end customers. So with the additional sort of assurance that you get from a confidential computing environment, many of these use cases can now get unblocked.
So Vikas, before we go to the final slide, there are a few questions that I wanted to kind of like ask and answer to an extent, and I'll ask you some questions as well, because most of you have heard this thing called Project Amber from Intel, right? We didn't talk about it much today, and the reason is because Project Amber was our code name, and we were doing previews of an attestation framework. We launched Project Amber, and it is a service under Intel Trust Authority right now. So Project Amber was just a code name, and Intel Trust Authority is the actual attestation service that you can leverage. We went GA, generally available, for Intel Trust Authority in September of this year. So first question. So Vikas, what's next when it comes to confidential computing? We spoke about all the things associated with computing. Now, what happens when people want to use something like a GPU or a domain-specific compute? I know that we're doing some work together on things like TDX Connect. Can you talk about it?
Yeah, absolutely. And I think one of the things that we should keep in mind is confidential computing has been a journey, right? It's a constantly evolving journey, and one of the things that we have seen is that the arc of innovation has rapidly increased over the last year or two, because this is when sort of the major CPU and GPU vendors have adopted confidential computing as one of the baseline capabilities that's going to be enabled in hardware for these sort of lift and shift workloads that don't require any sort of code modifications. So to answer sort of the arc of innovation here in confidential computing, it's going to be continuing to be a journey, right? Like HTTPS overall adoption did not happen over time. It took a while, and that's sort of what we see this happen as well. But we are seeing a bunch of these early innovators, early adopters doing a bunch of these workloads in production today. And what we hear from them is also they want to use this technology not just for CPU-based workloads, but also for GPU-based workloads. And one of the things that Satya announced on stage today with Jensen was the confidential computing, confidential GPUs that we are announcing today. And today they are aimed at small to medium models. But over time, we see the term that they use was SLM, small language models. And those models are great for sort of the capabilities available today. But if you follow this arc of innovation where computing eventually becomes confidential, the baseline capabilities that we are talking about here will eventually obviously make it their way in a very short time where you could run your AI models, whether there's for your virtualization, for simulation, for LLMs, in these sort of high capable models, high capable GPUs, which will enable that additional level of privacy where you're protecting the model weights, you're protecting the prompts that go into the models when you're inferencing against them. And over time, these capabilities just become standard foundational in what you expect essentially as the arc of innovation continues.
Yeah, to add to what Vikas is saying, right? Earlier this year, we announced a collaboration with NVIDIA, and the technology is called TDX Connect. And what is available today is a software way in which you attach a GPU or a bunch of GPUs to a trusted execution environment. It's great, but you want to get extremely high performance, and you want to make sure that you have a hardware way in which you connect this. And that technology is called TDX Connect, and we're working together with some of our partners. We're working with Azure in this particular regard as well. Now, the beauty of this, once you have all of these mechanisms built in, you can use the same kind of like Intel Trust Authority or Microsoft Azure Attest in order to attest not just your applications, but your workload, your models, and your data. Now you maintain an immutable record of where was my data, what was the exact snapshot of my data, what was the exact snapshot of the models, how did I go through the training, what was the environment under which I went through the training. So you can really go in, once you have this, you can explain all the elements that went in, and you can have keys that you use in order to release for the data or even the models to get decrypted inside of a trusted execution environment, and you extend it to domain-specific accelerators like GPUs in order to do that. So we believe that for a lot of enterprise use cases, these are bare minimum. It is very important for you to ensure that your data, your IP is secure, and what you use in order to train and what you use for inferencing is something that you know where exactly the origin of all of these things came from. And that's some of the things that we're doing from a technology perspective as we progress forward. Are there any last questions, Vikas, before we thank our customers here?
I think one of the things that I kind of touched on, and you did as well, is the evolution of AI and the evolution of sort of how attestation becomes a key element. Can you help me understand, or maybe talk to the audience about why do you feel that this sort of evolution is necessary for compute, right? Like going back to basics, if you may.
Yeah, at the end of the day, one of the fundamental reasons why this evolution is necessary is because we want to give our customers and our partners the ability to bring up productivity, the ability to kind of like take advantage of the flexibility that various types of computational infrastructure provide you, right? So when you want to take care of that flexibility, when you want to take care of that in order to drive productivity, you don't want to have this worry in your mind as to, okay, is my data secure? What are the bad actors who are kind of like attacking on the data? at any point of time, nobody will ever say that everything is 100% secure, but we are continually raising the bar with what we're doing with confidential computing, continuously raising the bar with technologies like SGX, TDX Connect, and TDX as well, raising the bar with some of the things associated with verification and attestation mechanisms. All of these things are going to make it a lot more harder for anybody to attack your data and compromise your IP. So this is why it's an evolution.
Yep.
Every time that we do something, we're going to do more, and you will get benefit from it.
Yep.
So I do want to thank all of you. We have all the resources and blogs available here for you to go and further verify. And at any point of time you have any questions, please do reach out to either the Intel or the Microsoft team, and we'll be happy to help.
Absolutely. Thank you so much for your time. And yeah, please reach out.
Thank you.